For this video, we are going to do a problem from the homework, and it's for Chapter 5 for the CHEM101 students. For homework question number 2, we are going to be given a number of moles of reactants and moles of products. So this question, let's break it down. Let's go ahead and read this as if it was a sentence. 1 mole of carbon dioxide reacts with 4 moles of H2 to produce 1 mole of CH4 methane and 2 moles of H2O. So this is actually a ratio. In your head, you already know that it takes 4 quarters to make $1. So you have a ratio in your head. It takes 10 dimes to make $1. That's very much like this. It takes 4 moles of H2 if you want to react 1 mole of CO2. So there's a mole-to-mole ratio there. So that's what I call it, the mole-to-mole ratio. I mean, other people call it. It's not mine. I do not patent that. I do not own the rights to that. But their question here is how many moles of CH4 are produced when 25.1 moles of CO2 gas react. So I like to write that down here. So how many moles are produced if I'm given 25.1 moles of CO2. So that's 25.1 moles. So if you remember back in your book, you have gram to mole, mole to mole, mole to gram. So I'm just going to write that generically, gram to mole, and then to mole, and then to gram. See, you have to, but this is what we use the mole to mole ratio for. This is the mole to mole ratio. What do I mean by mole to mole ratio? Let's find it out for this problem. It requires 1 mole of carbon dioxide to produce 1 mole of CH4. Why did I say that? Because they both have a coefficient of 1. So I can now deduce that. I can now figure that out. It's 1 mole of CO2 will produce, right? Will produce, you could write this any way. You could write it with words, but it will produce 1 mole of CH4. That's the same thing as saying 4 quarters, I can spell, will produce $1, right? So don't be hung up on what the word mole is. It's just telling you this amount, right? So moving on down, giving us some room. So I know that this is now a ratio. So you know how you could do a ratio of this is now a ratio that I can use to convert. So what do I always say? Start with your given, put them over 1. So 25.1 mole of CO2, put them over 1. What is my desired final unit? The question is asking for moles of CH4. So this is what I'm going to try to have in my numerator, right? The top of my fraction. So always have the desired unit on top, and you cancel out other things on the bottom. So what can I multiply this with in order to change moles of CO2 into moles of CH4? Use your mole to mole ratio. So it says 1 mole of CO2 for every 1 mole of CH4. So this is not the most intensive math that we've ever had to do. That just means it's 25.1 mole of CH4. Why? Because these cancel out and you're left with your desired unit. So the answer here is 25.1 moles of CH4. So this could easily have been a question of how many moles of H2 are necessary, right? How many moles of H2O are produced? So these are the kinds of questions that we need to practice and get used to in order to go forward and do be successful on the exam. So for this problem, we just did a mole to mole conversion. We only did this step. There will be times when you have to go from gram to mole, then to mole, then mole to gram. Those are the big long ones. Pack a lunch. We're going to go the whole trip. This one, they were already in moles, so I could just compare moles to moles. So did we have to do all this math? Maybe not. Because if you look up here, you know there's a 1-to-1 ratio. So 1 mole of CO2 will produce 1 mole of this. If I have 25.1 of this, I'll get 25.1 of this, right? So that is the long and short of mole-to-mole ratios for balanced reactions.